Okay, good afternoon everybody. My name's James Chaplen, I'm Head of Product Marketing at Mitsubishi Electric, and this panel discussion is all about accelerating clean heat, retrofit, efficient heat pump installation at pace. So if I could ask both Rob and Kim to introduce yourselves. Rob, can we start with you?
Hi, my name is Rob Hicks. I work for Sovereign Network Group. I've worked with them for 18 years. I'm a time-served apprentice, been in the industry for 40 years. I'm now a building services engineer, and I look after innovation and sustainability for them. So I look to the future to see where we might be, where we might need to go.
Thanks, Rob. Kim?
Yeah, I'm Kim Faulkner, Managing Director of a company called Faulkner Heating. We're based in Reading in Berkshire. We've been in the business now, in fact we had our 60th year last year, and we're heavily into air source heat pumps.
It's well documented that as about 17% of all UK emissions, which are thrown up into the atmosphere, come from heating our UK homes. And there's about 28 million homes in the UK. Just over 5 million of those homes are actually provided to the market by social housing providers. So the opportunity for social housing providers like S&G to decarbonise a huge amount of those 28 million homes is quite great. So firstly, Rob, if we could just come to you to talk a little bit about Sovereign Network Group, like your challenges, the size of your portfolio, where you operate, the type of properties that you offer to your customers. If we could start there.
So obviously at SNG, we've merged recently, so it was Sovereign Housing Association and Network Homes. Our demographic is, if you can imagine, from North London to Coventry to Forest of Dean, down to Exeter and the Isle of Wight and back again. So that's our operating area. 84,000 odd homes, and most of those are houses and our core stock profile, cavity wall homes, that type of home. 3-bed, 2-bed homes, and then flats. We have more flats in London.
Kim, you've worked with S&G and Ecodan for quite a few years. If we look back over that history, how has heat pump technology developed for you from an installer's perspective over that journey at time?
Well, I think we looked through our records. We probably fitted our first Mitsubishi Ecodan in 2010. I think then you had the FTC 1 unit, which is the control interface unit. Now we're on FTC 7, and I think over that period of time there's been improvements throughout the product.
So, Rob, could you just give the audience a bit of an idea as to what this project is, and I guess, where did the idea come from? What challenge was it that you were trying to...
So obviously the challenge really came from, how do we deal with our gas homes? How do we actually get people to move away from gas? The use of heat pumps, when we were looking at the transition from economy 7 homes into a heat pump, when I look back now, it's actually been really easy, because we had a technology that didn't really heat very well, we had a technology that was very costly to run, and then we moved into something as fantastic as a heat pump. So it was really a quite straightforward sell. And the upheaval, the disruption that comes with that, fitting a heating system, really was just had to be part and parcel of it, because we were changing such different technologies. But when we now talk about our gas homes, that's where the real crunch is going to come. And how do we really push all of the enablers and take away all the disablers? Now we know that with our gas homes, that if we go to change the system and we start the conversation straight away, where we're going to have to take out all the radiators and all the pipes, the conversation almost just stops dead there. But the next question comes, but could I have a gas boiler? Yes, you can still have gas boilers, they're still available. Will the heat pump significantly save me money? Not yet, but it will, but it's the right thing to do for the planet. Well, I'll stick with a gas boiler if you don't mind. And that's been the real difficulty. Everybody loves the technology. Everybody gets the idea. But this one solution, and I think it was an unintended consequence, of forcing people to change every heating system for potentially an efficiency figure, a SCOP, that's unknown. If you don't change the heating system, how much would it cost you to run when you don't do it? And that was the $1 million question for us.
So that 84,000 homes that you've got, how many of those would you say are currently running gas? Just to give everybody a scale of...
Around about that we would change to heat pumps, because not all homes we would change to heat pumps. There would be around about 45,000 of them. So that's the amount of conversations we've got to have on the scale of the task. Now, if we start that conversation where potentially you could go in and go, we don't need to change the radiators, we don't need to change the pipework, we can put a heat pump outside, we can bring some pipes into the airing cupboard, we can fit a new cylinder in the airing cupboard, we can reconnect it, we can do that in about 3 days. Everyone goes, wow, but where's the but? It might cost you a bit more money to run. And that was the question that we really had to nail down and understand. What does that drop off in SCOP? Because it will happen. How much is it really worth?
Come back to that.
Okay.
We'll come back to that question. To summarise the sort of statement issue, the issue statement that you had, getting everybody to move from oil, LPG, those sort of technologies, quite an easy sell. There's a cost benefit there, but you've got a huge estate of gas technology, running gas technology, where there's disruption to your tenants, there's potentially a higher cost to your tenants, and there's also a huge amount of them to do with quite a long install time if you want to bring down the cost for the tenant. Am I correct in my summary?
Absolutely, yeah, spot on.
Cool, right. We have got a small video, it's only 2.5 minutes long. We're just going to play that, which actually summarises the pilot project that we've been running between Mitsubishi Electric, Faulkner's and SNG, where we found 6 properties. We've done this retrofit that Rob's been talking about. So we've essentially kept the infrastructure in the properties, and we've just changed the heating technology that's fitting that system. And these properties actually use Microbore pipework. So we're just going to run this, and then we'll come back to Rob and Kim for some comments.
What are the challenges that you face in transforming and changing your gas housing stock?
Well, our challenges, George, are with the installation time and also minimising the disruption to our customers. When we go and retrofit an existing gas home with a low temperature air source heat pump, we'd have to go in and probably remove the entire system. So that would be the radiators, that would be the pipework, and that would also be Microbore. The Ecodan R290 is a high temperature heat pump. So what that enables us to do, we can use the existing Microbore pipe, because the Ecodan R290 has a flow temperature and a differential temperature that works like a gas heated home. So therefore we can use all of that existing pipework, all of that existing radiator system. With the installation costs, if we can go on to use the R290 air source heat pump, what that enables us to do is reduce the cost of all that disruption and all that pipework change that we would have had to do in the first place. We can then put that towards, say, solar panels or battery storage. So once you add that to the home, well, actually it's going to pull down that customer's cost quite significantly.
So the Ecodan R290 really provides a new solution to retrofitting a house that's got Microbore pipework.
Oh, absolutely. It's a game changer for us.
Massive game changer.
Yes.
That sounds absolutely fantastic. Thank you very much. Richard's arranged for me to visit one of their homes in Marlborough. I'm meeting their local heating contractor, Kim Faulkner. So Kim, we stand at the back of one of SNG's properties. Tell me a little bit about it.
Well, this is a typical 2-bedroom semi-detached house built in 2015. It had a gas combination boiler fitted with Microbore pipework.
But it hasn't got a gas boiler system anymore. We're standing alongside a Mitsubishi Electric Ecodan R290.
Correct.
This is a big deal, isn't it?
This is a massive change to the industry. The beauty with this unit is that we can utilise the existing system. There's no pipework to change. We can connect onto the existing Microbore pipework, existing radiators. The only thing we're going to be changing, or we changed, is the unit and the cylinder upstairs.
Did it take a long time to install?
This took about 2 days.
which is probably half the time a full installation would take. It's a game changer.
That's fantastic.
So Kim, coming to you first, Kim. When Rob came to you and said, I've got this idea, I've got 45,000 homes that I need to take the gas boiler out and put a heat pump in, and I need to do it quickly, and we need to keep the infrastructure there, what were your first thoughts?
Well, the first thing we thought about, and which is paramount, is to do detailed calculations. This is key to ensure that we get the right outcome. And the main difference for us as an installer was the time that it took to carry out the installation. As I said in the video, this was a 2-bed property. It took about 2 days. That was with 2 men. So total of 4 man working days to carry out the installation. And because we're utilising the existing pipework and the radiators, the disruption was kept to a minimum. Moving forward, I think the residents are going to be more perceptive to this technology, because we have found in the past that there's been a lot of apprehension in having an installation of a 5-day installation with the disruption that causes.
And the work that you had to do before you went onto site to start the retrofit, can you talk a little bit into detail around what that work involved, and how long was that work, how involved was that work?
We carried out a survey, which probably was a morning to carry out the survey to each installation. The calculations, with Robert's help, we utilised a program that gave us all the information we needed, and also the confidence that this would work. And so, as I said in the video, for us as an installer, it's a game changer. I mean, we can get to do a boiler change, for any installers here, it's a day's work. But to fit an air source heat pump and to have that technology running, and generally after 2 days, is, I think, a game changer.
How did you find the installation of the product as well? Like, how simple was it to make that change from technology?
Well, because the disruption is really minimal. We're using all the existing pipework. To all intents and purposes, it is like doing a boiler change, except that the boiler is outside.
Yeah.
And, it's the way forward as far as we're concerned.
Coming to you next, Rob. So, firstly, why was it R290? Why did you have to have that particular product to be able to kick this project off?
I think what you can say about R290 and why we got so excited about it 3 years ago when we knew it was coming over the hill towards us was it gave us really 2 things. It meant we could take a flow temperature up to 75 degrees C as and when necessary, and that's a big key point, as and when necessary. It also meant that with Mitsubishi's help, we could take the differential temperature up to 20 degrees. So now that meant every gas heating system, we were using the same design principles. So without doing the calculations, you know that if it worked as a gas home, it'll work as a heat pump home. And the software we actually used, there are others available, was H2X. And that gave us the confidence to do the calculations, do the maths, know exactly what it was going to do. How many litres per second, what the velocities were, mathematically calculated.
So I know Sovereign Network Group have got the 3 C's, you call them, don't you?
Yeah, we do. We put everything that we think about into either comfort, cost, or carbon. And what we mean by comfort is warmth and well-being. So it's our customers always come first. What we want is affordable warmth, and we want them to be well. Then when we think about cost, we put cost into 3 categories. We put it into capital cost, the amount of money it costs to actually buy it and do it. Then we have operational cost, the amount of money it costs to look after it. And then we have a cyclical cost, the amount of money it takes to service it and maintain it or stay compliant.
So taking all that into consideration and knowing that if you were going to run these products up towards their upper limit, how did you consider in the planning that cost element for the customer?
So obviously, the only real why not to this is it going to cost the customer more money to run? And if it does, how much is that? And that was the golden goose, if you like. So we took weather data from this property in Marlborough. The weather station's about 600 meters away from it. We took the minimum, the maximum, and the average daily temperature for every day for a whole year, and then we assigned the coefficient of performance to that temperature in relation to where it is on the weather compensation curve. We plotted it, and then we came out with an answer as to what we would think the SCOP would be for that home, and if we move the SCOP from that would be associated for a 75 degrees C weather compensated system to a 55 degrees C weather compensated system, what would the difference be? And it was quite a revelation. So taking SCOP and saying, what is it really worth? Because that is the cost to the resident. And SCOP is a unitless measure. It means nothing on its own. What really is the important thing is, how much does your heating system and hot water system cost a year to run?
And what was the number?
The number, if you had a £900 bill for that home, it would cost £104 more a year to run that system compared to a 55 degrees C1 weather compensated.
Is that comparing heat pump to heat pump?
Absolutely identical. Nothing changed. We ran the data again, doing it as 55 degrees C, fixed flow, and we would actually be £167 better off. So that the golden goose to this is, you absolutely need to use weather compensation. You absolutely need to get your heat loss and heat load as close as possible, and software like H2X will allow you to do that.
And so thinking about the future and this possible scale up of this type of rollout, have you had a look at what that change in technology would mean compared to the technology that you would be taking out in those properties? What might the tenant be looking at with just the straight swap from heat pump to boiler to heat pump?
So the cost variance, which Kim helped us with and we worked through, was by retaining radiators and pipework but cleaning it out, we could save somewhere between £2,500 to £3,500 per home. Now, knowing that the bill could potentially be for a resident £100 more per year, what we've chosen to do with that money is then go and spend it on PV. So that we know that from the work that we've done with Zero, another partner of ours, we've done the PV calculations, and we can generate around about £400 worth of electrical saving for those residents for that money. So we want to look at it in more of a holistic way. This isn't one solution, this is a solution. But what R290 absolutely allows you to do is replace a gas boiler with a heat pump, and you do not need to change anything.
And what does that realistically mean for SNG over the next coming years?
So if we think about, we've got 45,000 of them to do. Kim's already said we can do 2 a week, not 1 a week.
How many engineers does Kim have?
It's going to be busy.
The properties we saw there in Marlborough, I think we retrofitted 6 properties. Was that all in Marlborough?
Yeah, that's the one in Marlborough, yeah.
I know there's monitoring data there. So have we got any early signs, early data back from those sites?
So the early data is obviously beginning to pull back, but it's all around hot water, because obviously the heating's hardly been on most homes. We've had a diversity of homes, so we've had 3 beds and 2 beds. We've had houses, we've got bungalows, and that's where we use all of our heat pumps. What I would say from the hot water data is it already suggests, and we knew this from our calculations, is chasing around a SCOP for hot water is also a waste of time. Because if the hot water only ever heats to 65 degrees C flow temperature, you're only ever moving up from -3 air temperature to +20. You're only ever going up and down one Scott line. So at -3, the R290 will pull back about, I think it's 2.6 as a cop, something like that. Now, when you get up into +20, it's something like 8 or something ridiculous like that. So the building regulations ask for 2. So in my head, I'm already thinking the conversation about hot water and Scott, just forget it, park it. You don't need to think about it. What we do need to think about is Scott for heating.
So I know recently the Wave 3 of the Social Housing Decarbonisation Fund and the Warm Homes Plan now from government has been released, and S&G have been successful in getting funding for the future. So what does that now mean when wrapping up with this pilot project? What could that mean for not just S&G but for the decarbonisation of many more social
So
properties?
I think it has some really, really deep-reaching effects. We were successful with our Wave 3 bid for 4,500 homes. 4,000 of those would be direct gas replacements. So we've got to go and have that conversation with every resident and say, we want to take out your gas heating system and we want to put a heat pump in. And I've gone over how challenging that could be. And potentially we could have to have that conversation with 3 or 4 residents to get one to actually say, yes, I'd like to do it. But if we potentially do it this other way, I think we'd probably have one conversation and get one job, because you're going to be significantly better off with less disruption and less cost.
So we have flown through that way quicker than I thought. So I think unless there's anything else you want to add, Rob or Kim, to the topic.
The only thing I would say is that as a company, over the last couple of years, we've seen a sea change in gas against air source heat pumps. Probably a year ago, it was 60% gas, 40% air source. It's now going the other way. I think this year it will probably be 60%, maybe even 80% air source to 40% gas. So there is a change.
I mean, you can tell just shows like this. I mean, we've been coming to the show for, I wouldn't like to say how many years, but they probably need to rename it, not Install the Show, but the Heat Pump Annual Show. To be honest, it's developing very, very quickly. The QR code, which is up now, takes you to our landing page where all of this sort of technology and work that we've been doing, especially with small bore and microbore pipework. There's a white paper there, there's a case study there. You can register for a CPD with our team as well. And just leaves me to say thank you all very much for coming and joining us, and I hope you enjoy the rest of your day. Thank you.
Thank you.